All right, let's get right into it. You hear about cloud security all the time, right? But what actually matters? What we're going to do here is cut through all that noise and focus on the top 10 cloud settings that are the real reason for major incidents on platforms like AWS and GCP. No fluff, just what you need to know.
Here's the thing you have to understand. The breaches you read about in the news, they almost never start with some super complex Hollywood-style hack. The truth, it's way less exciting and, frankly, a lot more preventable.
Yep, you heard that right. The most destructive breaches often start with something tiny. A single checkbox that was clicked by mistake, a permission that was just inherited from some old policy, or my personal favorite, a temporary admin access that was given out during a late-night fix and then, well, just forgotten. Sound familiar? This is just reality for teams trying to move fast.
Okay, so that leads us right to the real root cause here. See, these little slip-ups, they're not random. They follow a predictable, almost boring playbook that attackers have learned to exploit over and over again.
And this is the playbook. It's a pretty simple 4-step process. First, exposure. Something gets left open to the internet. Second, discovery. An attacker finds it. Third, the privilege hop. They use one small permission to wiggle their way into a much bigger one, moving around inside your network. And finally, exfiltration. Your data just walks right out the door. The headline makes it seem like it happened overnight, but the reality is the groundwork for that attack was being laid for weeks.
So really, you can boil this entire problem down to a simple formula. You take an exposed surface, like a public storage bucket, you add a weak identity, like a role that can do way too much, and you top it off with missing feedback loops, meaning you have no alerts to tell you something's wrong. That combination is the trifecta that leads to a breach.
All right, so let's get into the specifics. This is the incident hit list. And don't think of this as just a boring checklist. Think of it more like a map of the super highways attackers love to use to get from that first little opening all the way to your crown jewels.
So group number 1 is all about the open doors. Of course, you've got the classic, the accidentally public S3 bucket. But it's also things like admin panels for SSH or Kubernetes that are just hanging out on the internet. Then you get the sneaky ones, like trust policy mistakes, that let an attacker literally jump from one of your accounts to another. And finally, unrestricted egress. Basically, the back door is wide open and no one's watching what's leaving.
Group 2 is where a small problem becomes a huge one, identity risks. Using wildcards in your IAM policies, that's like giving someone the master key to the entire building when all they needed was to get into one room. Then there's service account key sprawl. I mean, these keys are just everywhere, left in code, sitting on developer laptops, you name it. And finally, weak encryption key policies. You think your data's safe because it's encrypted, but if the key policy is bad, it's like locking a door and leaving the key right in the lock. And the final group, these are the risks that just creep in over time because of neglect. Things like turning off audit logging, which makes you completely blind to an attack, or orphan snapshots, these old backups that nobody even remembers exist, but they're packed with sensitive data. And maybe the most dangerous of all, that one giant exceptions file that was supposed to be temporary, but has now basically killed the entire security policy you worked so hard to build. And this is a perfect example of why those forgotten things are so dangerous. There's this story about a team that found a 3-year-old backup from a project that didn't exist anymore. Nobody owned it, and it was full of raw user data. The console said private, but if no one owns it, is it really private? It was a ticking time bomb just waiting to go off. Okay, so we've laid out all the problems, but that brings up another huge issue, right? When everything looks critical, how do you prioritize? Well, the key is to stop thinking like a defender and start thinking like an attacker.
I mean, let's be real. Most security teams are just drowning in alerts. You log in, you see 1,000 things screaming, critical! So where do you even start? How in the world do you decide what to fix first?
Well, you start by changing how you think. The old way, you're just looking at how old a ticket is, or some generic severity label. That tells you more about your ticketing process than your actual risk. The new way, the smart way, is to think in terms of blast radius. You analyze the actual path an attacker can take and focus on the real-world impact.
And honestly, it comes down to asking 2 incredibly simple questions about any alert you get. Number 1, is it externally reachable? Can an attacker on the internet get to it? And number 2, can it escalate privilege? If they get to it, can they use it to get more power? Think about it. A medium alert, where the answer to both of those is yes, is 100 times more urgent than an isolated critical one where the answer is no.
This really brings it all home. If the fix you're about to spend time on doesn't actually take options away from a potential attacker, you're just doing maintenance. You're not actually reducing risk. That has to be your filter for everything you do.
So now that we know how to prioritize, let's talk about getting ahead of this whole mess. We need to move from just finding problems to actually preventing them from ever happening in the first place. We need guardrails that actually stick. The strategy is a simple sequence: prevent, detect, and prove. But here's the trap most teams fall into. They spend all their time and money on detection, finding stuff that's already broken in production. The real magic, the real leverage, is in prevention. Catching these things in your CI/CD pipeline before they ever see the light of day.
So what do these guardrails look like? For identity, you've got to move to short-lived credentials and just-in-time access. For your network, it's simple. Deny by default on the way in and be super explicit about what can go out. For data, this is a big one. Block public access at the org level, period. And for change, use policy as code and, this is key, make your exceptions expire automatically. No more temporary permissions that live for 3 years.
All right, that was a lot of information, I know, but theory doesn't mean much if you don't do anything with it. So let's nail this down with one single concrete step you can take, like today, to actually reduce your risk. I call it the 60-minute sweep. And I'm serious, just 1 hour. Get one person from security, one from platform, and one from an app team into a room. Forget about debating grand architecture. For this hour, you focus only on the big exposure risks we talked about. And here's the rule. For every single thing you find, you assign an owner and a non-negotiable 7-day deadline to fix it. And to make sure this actually sticks, you need to track one metric, just one, your North Star, the number of internet-exposed critical findings you have in production. That's it. That number tells you the truth about your risk. And your only job, week after week, is to make that number go down. So I'll leave you with this one last question to think about. If your boss walked over to your desk right now and asked, "Are we exposed?" Could you prove that you're safe in the next 30 minutes? Because if you can't prove you're safe that quickly, you probably can't contain a breach that quickly either. And that is the real test.